Hello students, welcome to third episode of Electric Charges and Field. Here in this episode, we will be covering electric field intensity, electric field due to the point charge and the number of charges. Then we go for electric field lines, the various properties of electric field lines and how to draw the electric field lines. We end the lecture with some problem. So let's start the lecture. What is electric field? Let us understand the meaning of electric field. Suppose a charge plus q is placed at point O. Okay. Now another charge small plus q is placed at point P. Then what will happen? As per Coulomb's law, what we have studied, that this charge q will exert a force at point P. And what is the magnitude of that charge? The magnitude of that charge will be 1 by 4 pi epsilon naught q by r square. This is the force which is exerted by this charge plus q or at this point P. Okay. Now suppose if I remove this charge small plus q from point P, then what is left here at point P? So that we need to study. So after removing this charge, if the charge plus q was there, there would be a force at point P because of this charge. But if I remove this charge from here, then what is left here? That is nothing but a electric field. That is, here the electric field is left that is produced by this charge plus q. So what is electric field? That is the space around the charge in which the electrostatic force of attraction or repulsion can be experienced by another charge. So here if we go in reverse, so we can say this plus q charge will experience a force because of the presence of electric field at point P, and that electric field is produced by plus q charge. Okay, so we can say electric field is nothing but the force experienced by that charge particle. So what is the formula for force? 1 upon 4 pi epsilon naught q by r square, and that is divided by q. So the magnitude of electric field will be this. This is the magnitude of electric field for a point charge. Electric field intensity. So electric field intensity gives you the strength of the electric field. Okay. So how can we define the electric field? It is the force experienced by the unit positive charge placed at that point. So if I need to define the electric field, then it is the force experienced by the unit positive test charge. Okay, and the SI unit of electric field is Newton per Coulomb. That is the SI unit of electric field. Okay, so if I take here the charge plus Q, and here is the unit positive test charge, that is the unit positive test charge. Okay, so this produces the electric field around that area. So this is called the source charge, and that is used to detect the presence of electric field. So this is called test charge. The charge which is producing electric field is called source charge. Okay. So now how do we predict the direction of electric field? That is the very important thing. So if your source charge and test charge both are of same sign, similar sign. So direction of electric field is what? away from the source charge. That is the direction of electric field. But if your source charge and test charge are of opposite sign, then what would be your direction of electric field? Direction of electric field is towards the source charge. This is very important thing that you need to memorize. How do we find the direction? So if the two charges are of opposite sign, that the direction is towards the source charge. It is not necessary that here if the charge is unit positive charge, then you just have to consider that as a positive charge. Suppose if I just take here the charge Q1 and Q2, okay, and suppose if I take this as positive, this is negative, okay. So here I need to find the direction. I need to find the direction of force, or I need to find the direction of electric field here. So here I can consider any one of the test charge. So if if I consider this as a test charge and the direction of this as a test charge, then this would be the source charge. If both the direction is opposite, then it is towards the source charge. And if the direction is same, if the direction of both the same, then, and that is the test charge, so that the direction is away from the source charge. That is the direction of force here, that is the direction of force here. Electric field due to the point charge. Now we just able to know that what is the magnitude of electric field due to the point charge. For a single point charge, the electric field is given by 1 by 4 pi epsilon naught q by r square, where this q is what? Your source charge. So when and when we express this in vector form, then it would be like E is equals to 1 by 4 pi E naught q by r square, and we just multiply this with a unit vector r. And for the system of point charge, means if suppose you have charge q1, q2, q3 like that, and this here is a test charge. Now you have to find the electric field due to the system of these charges. So how can you find the electric field? You just have to find first the electric field because of all the three charges, and then after you need to find the resultant of that charge. So resultant of here E1, E2, E3 gives you the electric field due to the charge Q1, Q2, Q3. So similarly, if you have n point charges, then the electric field, the strength of electric field can be given as 1 upon 4 pi epsilon naught Qi Ri square into Ri unit vector, where your I goes from 1 to n, means you have n charges, and because of that n charges at a particular point P, you need to find the electric field. Then we just have this formula for that. Now we have done that electric field, the charge, a single charge produce electric field. Okay, so whenever it produce the electric field, then if we just discuss about that shape, then its shape is always spherically symmetrical. Suppose this is a charge plus q. Okay, this is a charge plus q. So it produce the electric field around it, and the shape of that electric field is what? Spherically symmetrical. Electric field lines. So what are electric field lines? It is nothing but a path along which your unit positive charge travel. Okay, so suppose if this is a path along which the unit positive charge travels, this is electric lines of force. So if I just want to predict the direction of electric field at a particular point P, then how can I predict? What I just draw the tangent along this. So that tangent gives me the direction of electric field at this particular point P. If I just want to find the direction of electric field at a point Q, so what I just do, I draw the tangent, and that gives me the direction of electric field at that point Q. Okay, so what is electric field line? It is a path, straight or curve in electric field such that tangent to it at any point gives the direction of electric field. Properties of electric field line. So what are the properties of electric field line? The first important properties is that they form continuous curves. They form continuous curve but not form continuous closed loop. Why they don't form continuous closed loop? What does it mean? And why they don't form continuous closed loop? So they form continuous loops means they always starts from the positive charge and ends at the negative charge. Okay, so therefore they form a they form a continuous curve, but they don't form the continuous closed loop because they always starts from positive and end at negative. For a positive charge, it starts from the positive charge and end at infinity. For a negative charge, it starts from infinity and end at negative charge. So they don't form continuous closed loops. The second is tangent to the electric field line at any point gives the direction of electric field. That I have already explained you, that if it is a curve, it is a curve, then at any point if you draw the tangent, then direction of that tangent gives you the direction of electric field at a particular point. Okay, that is what the second point says. No two electric lines of force intersect each other. If suppose the electric lines of force are coming from a particular region, so the two electric lines of force will never intersect each other, because if by chance they intersect at a particular point, then at that point there would be two direction of electric field at the same time, which is not possible. Okay, so that's why the two electric lines of force never intersect each other. And the important point is that they always perpendicular or normal to the surface. The no component of electric field is parallel to the surface. So if it is a surface, the electric field line always falls perpendicular to it. Okay, so if by chance it is asked this question that why they don't form continuous closed loop, so your answer will be because they starts from the positive charge and end at negative charge. Strength of electric field. So how do we find the strength of electric field? If suppose I say the charge plus Q, so this charge produces the electric field lines that what I have drawn. Okay, so if it is asked to predict the strength of electric field, whether your electric field is stronger or weaker in that particular region, then how would you find that strength? So the strength of electric field is you can calculate by just finding the density of electric field lines. If the electric field lines are more denser in a particular region, or we can say if they are more closer to each other, then the strength of electric field at that region would be stronger. So if I just say this region, okay, if I just need to calculate the region electric field here, or the region in this region, if I just need to find the electric field, or here if I need to find the electric field, so I must say the if E1, E2, E3 are the strength of the electric field, so I must say E1 is greater than E2 than E3, means the strength of electric field at E1 region would be more stronger than E2 and E3. Why? Because here the electric field lines are more denser, more closer to each other. So if I say electric field line are more closer, then at that reason the electric field would be stronger. uh, Electric field lines. How to draw the electric field lines? So from the properties of electric field lines, what we understood that the electric field lines, they starts from the positively charged particle and end at negatively charged particle. So for the positively charged body, it goes from positive charge to infinity, and for the negative charged body, it comes from infinity to negative charge. So if it is a positive charged body, so how can we draw the electric field lines for this? That is radially, the direction would be radially outward. Okay, and for the negatively charged body, the direction is radially inward. That is for the single positive or negative charge. If it is asked to draw the electric field line for a charge q is less than 0, means the charge is negative. So here in that case you need to draw this diagram. And if it is asked draw the electric field line for a charge q is greater than 0, means q is positive, means the electric field lines is radially outward. And here it is given that the two charge, the q1 is here positive and the q2 is negative. So how could you draw the electric field line for this? Same way, for positive charge, the electric field lines are radially outward. So it is radially outward from here and from here also. And for the negatively charged, it is radially inward. So it enters in the negatively charged body and it goes out from the positively charged body. So this way we can draw the electric field lines. One more, if it is asked to draw the electric field line for a infinite thin sheet of charge, positive, this is a positive sheet of charge, and for this if you need to draw the electric field line, so this is positive sheet, so the electric field line direction is outward. For here also the direction is outward. So in this point, from if you just see from this point of view, the direction would be outward. So in this way you can draw the electric field line for a thin infinite sheet of charge. So let's elaborate the concepts through questions. So we have a question, 2 point charges of plus 16 microcoulomb and minus 9 microcoulomb are placed 8 centimeter apart in air. Determine the position of the point at which the resultant electric field is 0. So here what is given, plus 16 microcoulomb and minus 9 microcoulomb. These are the two charges. Okay, and the distance between them is how much? 8 centimeter. Now we have to find the position where the resultant electric field because of the two charges is 0. So now I just consider that at a particular point, here is the P is the point where the resultant electric field is 0. This P point is suppose at a distance x from point B. Okay, now we need to find the direction of electric field. So this is very important thing in order to solve this question. So here this P point, that we can consider as a test charge, and this is source charge. So what I told you, test charge, that is always positive, unit positive test charge. What I told you, if source charge and test charge, both are of same sign, then क्या होता है, the direction of the source charge, the direction of the electric field is what? Away from the source charge. So what even is the electric field due to the charge plus 16 microcoulomb. Okay, now if you see here that the two are of opposite sign, ये दोनों ही opposite sign के हैं. So here in that case your direction of electric field will be towards the source charge. Okay, so this thing you just need to memorize ki how do we find the direction of electric field. If both are of same sign, direction is away from the source charge, and both are of opposite sign, direction is towards the source charge. Now how can I calculate their magnitude? How can I calculate that magnitude of E1? E1 is due to the charge plus 16 microcoulomb. So that is what 1 by 4 pi epsilon naught 16 into 10 raised to power minus 6 coulomb upon the distance between A and P is 8 plus x into 10 raised to power minus 8 plus x square into 10 raised to power minus 2 square, which is equals to minus 4 if I convert this into meter. Okay, and E2 is the electric field because of charge minus 9 microcoulomb. Okay, so 4 upon 1.4 by epsilon 9 into 10 raised to power minus 6 upon 8 upon x square into 10 raised to power minus 4. So here we don't put the sign negative. The use of this negative sign is only to predict the direction of electric field. Here we don't consider the negative or positive sign. We always take the charge here with the positive sign. And why I have put that minus 4 into 10 raised to power minus 4? Because that is in centimeter. In order to convert this into meter, 10 raised to power minus 2 ka square. So that will become 10 raised to power minus 4. Okay. Now, what is my net electric field? Net electric field is what? E1 minus E2. That is my net electric field, E1 minus E2 or E2 minus E1, which one is greater? You just need to subtract that, and it is the question that is given. The net electric field at point P will be 0. So we can say E1 is equals to E2. So what is my E1? E1 will be 1 by 4 pi epsilon naught 16 into 10 raised to power minus 6 upon 8 plus x square into 10 raised to power minus 4, and my E2 will be 1 by 4 pi epsilon naught 9 into 10 raised to power minus 6 upon x square into 10 raised to power minus 4. Okay. Now this and this will cancel out. This and this ये भी cancel हो जाएगा, and what will remain here is 16 upon 8 plus x whole square is equals to 9 upon x square. Now what can we do in order to simplify this? Better if you take square root on both sides, then this becomes 3 by x. Now if you multiply this, so x will be 24 centimeter. So at a distance of, because x was in your centimeter na, so here you just need to put centimeter sign. So at a distance of 24 centimeter from charge minus 9 microcoulomb, your net magnetic field will be 0. See one more question. Here is a question. 2-point charges plus 5 into 10 raised to power minus 19 coulomb and plus 20 into 10 raised to power minus 19 coulomb are separated by a distance of 2 meter. Find a point on line joining them at which the electric field intensity is 0. So here what we need to calculate, we have 2-point charges, this and this. Okay. We need to find a point, and they are separated by 2 meter apart. So we need to find a point on the line joining them at which the electric field intensity is 0. Suppose if I consider this is a point P where the net electric field is 0. So, how can we find the direction first? How can we find the direction of electric field? See, this is my test charge now and this is my source charge. Both are of same sign. If both are of same sign, then the direction of electric field is what? Away from the source charge. Now this is my for this source charge, this is my source charge, this is my test charge. Now direction of the source charge, direction of electric field, both are of same sign. If both are of same sign, direction of electric field will be away from the source charge. Okay. Now, how can we find their magnitudes? So, if we consider at a distance x from point A, the electric field is 0. So, E1, the magnitude of E1 will be 1 by 4 pi epsilon naught 5 into 10 raised to power minus 19 by x square. What is the magnitude of E2? 1 by 4 pi epsilon naught 20 into 10 raised to power minus 19. What the formula we are using? 1 by 4 pi epsilon naught q by r square. Here this E1 is the electric field due to this point and E2 is the electric field due to the charge this. So that will be 2 minus x whole square. Now we will see the net electric field is what? Net electric field is here again E1 minus E2, or which one is greater, you can subtract that, and then the net electric field at P is 0. That gives you the value of net electric field. So E1 is equals to E2. Okay, so E1 is how much? 1 by 4 pi epsilon naught 5 into 10 raised to power minus 19 by x square. E2 is 1 by 4 pi epsilon naught 20 into 10 raised to power minus 19 by 2 minus x whole square. Now, how can you solve this? This and this will cancel out. 10 raised to power minus 19 bhi cut jayega. So, what we get here? 5 by x square equals to 20 by 2 minus x whole square. So, this also we can cancel out. So, 1 by x square is equals to 4 upon 2 minus x the whole square. If we do square root on both sides again, so we will get 1 by x equals to 4 upon 2 minus, 2 upon 2 minus x. So, we will get 2x equals to 2 minus x, or 3x is equals to 2, or x will be 2 by 3 meter. So, we can say that the net electric field will be 0 at point P, which is at a distance 2 by 3 meter from the charge 5 into 10 raised to power minus 19 coulomb. So, here we have finished the concepts related with the electric field and electric field intensity. The rest part of the chapter we will covering in our next episode. So, keep practicing.